Welcome to Data Science Perspectives. This series focuses on analytics and data science professionals from across industry to learn about how their career unfolded, what skills they look for when hiring, and what trends they think are coming next. I'm your host, Bill Franks. Let's get to it. Welcome to this episode of Data Science Perspectives. I'm your host, Bill Franks, and today we're going to be joined by Taylor Horton, the Senior Director of Data Science at Cox Automotive Group. Now, for those of you who aren't familiar with Cox Automotive, they're actually a $20 billion a year business that has offerings that cover virtually every aspect of the end-to-end automotive space. Some of their best-known brands include Auto Trader, Kelley Blue Book, and then Manheim in the auction space. I probably met Taylor initially about 10 years ago when he first joined Cox, and I haven't been at all surprised to see his career take off. One of the things that's driven his efforts has been how technology disrupted the entire automotive space. When you look at sites like Auto Trader, they've been at the forefront of that, and I think we'll hear a little bit about how that's played out today. Now, he's got a undergrad in economics from Clemson and a master's in economics from Johns Hopkins. He's previously been a consultant with Deloitte, and he also spent some time with the Bureau of Labor Statistics. So I think as we chat here today, you're going to see he's an all-around nice guy, and I think we're going to get some great insights. So with that, let's welcome Taylor to the show. Well, hey, Taylor, thanks for joining me today.
Hey, thanks for having me, Bill.
So, I thought we'd start. I'm not sure that the average person understands how big Cox Automotive actually is. Can you maybe provide a quick overview of what you all do and its overall mission and some of the companies that comprise your organization?
Sure. Yeah, it's a good question because I think similarly, a lot of folks don't understand sort of who we are and what we do. So Cox Automotive is, our mission is to basically change the way that people buy, sell, and own cars. There's about 25 brands inside of our business and about a little over 30,000 employees across our company. And we touch probably 3 out of 4 transactions, automotive transactions within North America, and we have an international footprint as well. So quite large. Brands you may be familiar with are Auto Trader and Kelley Blue Book. We also have Manheim, which is the largest wholesale auction company in the U.S. and in the world. And the way I like to describe sort of what it is that Cox Automotive does, we don't buy, we don't own cars, we don't sell cars. But mostly if you stick a car dealership kind of in the middle of a circle and you surround that car dealership with everything that they might need to run their business effectively, again, things like wholesale auctions or access to financing, we offer that from a wholesale standpoint, buy cars from wholesale, sell cars from wholesale, finance cars from wholesale. And then on the retail side of your transaction, we offer, again, all those different services that they might need. And that includes things like Auto Trader and Kelley Blue Book, which might be marketing solutions for them to get their inventory out in front of other shoppers. It could be CRM, to help them manage the customers that come into their store. CMS, a web presence to help them get out there on their own websites, as well as all the software that you can imagine that runs an actual dealership. So it could be the service lane software, the financing connection software, the sales software, all the things that sort of interact on the dealership side. And so it's really a full service suite. And then, that's sort of the market we aim at dealers. And then there's all sorts of other things that we do aimed at manufacturers and also sort of these new mobility solutions. So things that support rideshare, autonomous vehicle companies and other things that we might do there, including fleet management, fleet servicing, et cetera. So lots of service, essentially anything in the automotive space that isn't buying and selling cars directly is something that Cox Automotive often plays in.
Wow, that's a lot of stuff. And if I recall, all of those things together add up to tens of billions of dollars per year, right?
Yeah, that's right. A little over $7 billion a year in revenue.
Okay. So, everything you just described, obviously there's a lot of data that's involved in that. And then I'm presuming a lot of analytics. So I'm guessing your team stays pretty busy supporting all of that activity that you just talked through.
Yeah, that's right. So we're a center of excellence data science team. So we sort of sit in the middle of Cox Automotive and support all 25 of those brands. And to your point, data is really important. And partly is because of the way that I described how our business works. we want to understand every part of the automotive ecosystem, every part of the transaction, from that car initiating, rolling off the factory floor, to making its way into its first retail transaction, the ownership process, what customer has it, what types of parts and service and maintenance they may need over time, to when they sell that car back, to continue on, whether that goes to wholesale, et cetera. So the entire ecosystem of a car, as it passes through its life journey, from the initial transaction and all the other transactions, are key touch points. And so what we try to do is make sure that we, through all of our various businesses, that we have data at each one of those touch points. And importantly for us, that we understand how those data connect to one another. The better that we understand the connections between those data, the better we understand and we can service each one of our individual marketplaces. So an example might be Kelley Blue Book is known for their pricing, which is something that our team works on, our data science teams work on. In Kelley Blue Book, you get retail pricing if you're going to go buy a car from a dealership. You get private party pricing. If I were to sell my car to you, Bill, you could go figure out how much you think you should pay for it. We get trade-in pricing and wholesale pricing. And the only way we can do that is by looking across all the transactions that we have, data partners that we can work with, to get a full understanding of that marketplace, so that we can understand the prices of each one of those components. We also have Manheim pricing, which does a very similar thing in more detail on the wholesale side. So that's just an example of where having access to data across the entire life cycle and then understanding how those data connect to one another allows us to do some really powerful analytics.
Yeah, it's interesting too. I know you came educationally from an economics background, and everyone seems to get into data science from different angles. Unless you're in the last few years when degree programs have popped up specifically focused on it. But what initially drew you into this world of analytics and data science once you got out of school?
Yeah, that's you know my background too well, Bill. So I initially went into econ. I didn't know what I wanted to do. I knew I wanted to be somewhere around business, and I knew that I had an interest in math, and so econ just sort of seemed like the obvious choice. And I think once I was in undergraduate, I was really fascinated in the way that degree helped me understand how businesses think about their world, and how shoppers and consumers and individuals think about how they go about things. And so I became really fascinated in that. I spun off and did a tour of duty as a statistician in the Bureau of Labor Statistics before going into consulting, and then eventually making my way into industry. And what I found really interesting was just the tools that you can use within analytics allow you to solve lots of different problems using sort of a basic tool set. So the tools of economics, the tools of data science, the tools of analytics, they give you tools to think about problems and how to solve them with data, which to me is really, really powerful, really interesting. Because I think something that I learned throughout my career was that so much of our decision-making process in business is driven by uncertainty. And data is a really nice tool to help you sort of try to reduce that uncertainty if you can, make better, more informed decisions. And so I found the entire process of trying to get clarity in situations that were murky, reduce uncertainty, to be one, just a fascinating process, and two, the technical interesting challenges of working with data, working with software, working with technology were also interesting. So those were all the things that kind of piqued my interest as I sort of moved through my career into the space.
Yeah, it's funny. I think a lot of people, you get the bug in a way, right? People who are into it, once you experience it, you're just into it, and you get sucked in. When you think about it, you've had a pretty successful, varied career. If you think back, both prior to Cox, at Cox, what have been one or two of the skills or traits that you have that you think have best enabled you to succeed in this space?
Yeah, it's an interesting question. I'm certainly a little bit of luck and timing. I think is always important. But for me, there are I think a few things that have helped me. Going back to kind of your previous question, I didn't know what I wanted to do when I went into undergraduate and eventually graduate school. And what I'm doing now didn't exist at the time, right? Data science wasn't a term people talked about. And a lot of the work that I do today, I didn't know about anyway. I didn't know about, how marketing worked in the way that we work with it today, or, digital and technology and websites and personalization and ad targeting. All those things were sort of not really around at the time. So I think one of the skills that or traits or things that has allowed me to sort of be where I am today is sort of always being open to those opportunities, seeing whatever I could that was in front of me that was interesting and trying to pursue it. And then once I got a little bit further, more of the world opened up, more opportunities sort of showed themselves. And then being able to identify that next opportunity and pursue it. That way of sort of bouncing through my career certainly helped me end up in a place where I was both doing things that I'm really interested in and passionate about, but would not have known were available or options to me, 15 years ago. I think the other thing for me is being able to take technical skills that I had, hard skills that I had, whether that was, software, skills, programming, et cetera, technology, or data science skills, data statistics, econometrics, et cetera, and applying those to areas of businesses that weren't as mature in either one of those verticals. And so that gave me a ton of leverage because I was taking skills that even for myself weren't necessarily very, very refined. I wasn't the best statistician or the best programmer, sort of classic data science, but I was working in places that had little to no experience in either one of those fields. And so what I was able to bring was really unique, really valuable, really high leverage. And that helped me get started and move sort of up to the middle part of my career where then, I was able to continuously learn and build out new skill sets.
You made an interesting point about kind of almost creating a career path for yourself. I know a lot of people who have been in this field for a while, like you and myself, effectively had to do that. I think what's interesting today, there actually are some standardized career paths out there if you want to go that route. In other words, you can get hired in as a data scientist and work your way up in a line scenario. But it seems to me, and I'm just curious if you would agree with this, that even today, though, there's still the ability to kind of chart your own course as well. As new algorithms are coming out with the whole AI boom, new data sources and such, you also, I don't think, lack the opportunity to kind of forge a path that you find interesting today, even as the field's more established.
Absolutely. I mean, I think that's, my hunch. I mean, I have my own experience and certainly shared a little bit of yours. My assumption is that's the way it's always been. I think that'll continue to be the way in the future, mostly because we're not very good at forecasting this type of thing. We have some general idea of what things might look like in the next 5 years, but if you go across the span of a full career, 30 years, there's no telling what the world's going to look like, what the problems are going to be, what technology is going to exist. And so, yeah, I think you, and I would just say, I mean, I think most people probably, even if you think you have a really great, perfect idea of what you want to do, I think you'll learn throughout your career, even if it's within data science or analytics or algorithms or AI, you may find the types of problems that are more interesting to you, whether you're more onto the algorithm development side or maybe more on the stakeholder management side. So I agree. I think there's still an opportunity to sort of pave your own path, and as long as you can just get started and you can start to get experience and you can start to stay curious, then there's always opportunity to continue to sort of move through the future. Because again, even what we're doing today probably won't be the way that they'll do it in 10 years. And I think everyone who's sort of entering their careers at least, and keep that in mind as you sort of move forward.
That's a great segue, by the way. I was going to say that's some really good advice for the students in our programs at KSU to hear. So let's dig into that one more. Speaking of people who are looking to get into this field, whether you're literally a student just coming out of school or maybe trying to do a career switch, what's one thing that you wish someone had told you before you started working that you figured out the hard way?
Yeah, it's probably a softer answer than I wish there was something really easy. But for me, the thing that I didn't understand that I wish someone had sort of explained to me better was that business is all about working with constraints, and that to me is the biggest difference between the academic parts of my life and the business parts or the industry parts of my life, which is every problem that we face in business has some constraint on it. And the biggest thing that I think that I work on and I try to get my teams to work on is identifying those constraints so that you can properly understand the problem you're even working on. Everyone talks about the importance of elicitation and understanding the problem you're working on so that you can solve it correctly. But to me, that's all about understanding the constraints that you're under, whether that's time or cost, or maybe your algorithm can't be too sophisticated because it needs to be easy to implement, or maybe your stakeholder is not very far along in the maturity curve, and so you need to do something that's easier to explain to them, maybe not from just so that they can get bought in early. So those are the types of things that I think are really important from a constraint standpoint. And all the skills that you learn in school are just sort of cliche to say the tools in the toolbox, but those are the tools in the toolbox so that once you really understand the problem and the constraints that you're under, you can apply all the hard skills that you've learned to find the best right solution for that. The best algorithm, the best approach, the best technical implementation, the best stakeholder management and soft skill approach to working with the stakeholder. So all of those things are really important, but I don't think I quite understood that. It's also cliche to say that the data is not as clean as it is when you get it in a classroom, and it's partly because I think all of those constraints that live up, and so once you enter industry or once you enter your first job, I think you'll quickly start to see what those constraints are. And so my advice would be seek out and really try to understand those constraints. Make sure that you're pushing on the people you're working with or your manager or whomever else to understand the problem really well, and why you're doing something a certain way, or why the approach of your team or your company is a certain way, and those constraints will be revealed. And I think that'll give you clarity on how to better solve problems.
That's funny. Constraints. They're so important, and oftentimes you've got to dig around to find them, because I'm sure you've experienced it. I've experienced it where you or a team you're managing goes and creates something that ostensibly is really cool and seems to work great, and then you go take it to the business sponsor, and the business sponsor's like, well, yeah, but if I took this information and acted on it in the way that you're suggesting, either A, that's illegal, or B, our systems can't handle it, or C, it goes against our strategy that we set for next year. Something that wasn't related at all really to the data and the algorithms itself, but that was critically important to getting it used. And I know that those are those lessons. You do it once or twice, and you hope you never have to live through it again, because it's incredibly frustrating and a bit embarrassing at that too.
Yeah, and I think there's also the relationship between those constraints, because sort of an easy example might be if you're building an algorithm that can be deployed in batch versus say like it needs to be on a stream, it needs to be like very real time. If you propose a solution that's real time, and nobody has any real-time infrastructure, then now the time it takes to implement that is much longer. So if time to implement is a constraint, and then you recommend a solution that adds a lot of complexity or a lot of work, then you can blow up one of your very obvious constraints with something that may not have been as clear to the stakeholder. They're not going to tell you usually, oh, it needs to be batch, it needs to be streaming, it needs to be this, it needs to be that. So you have to sort of understand what those sort of second and third order constraints are, so that you can make sure that you can try to deliver something on time, or to all the points you made that meets what they're trying to do.
It's funny. There's a term I've used over the years of, decision time. What's the time of the decision? And, there's this desire sometimes, oh, wow, we're going to build this real-time process that's going to update everything as soon as it hits the system, and this and that. And of course, that takes a lot more cost and a lot more engineering and a lot more under the hood work to make something work real time. But if at the end of the day, someone has to make a decision each night, what are we doing for tomorrow? It actually doesn't add any value to get that to real time. And you've spent a lot of time and resources, and you've added complexity. And anytime you add complexity, there's more things that break. And so I think that it gets back to a constraint of sorts in tying these together. There's this aspect that of focusing on what do I really need to do, and what are the constraints around that, and focus on crossing that bar initially, not by a mile, but just getting over the bar so that you can get something in place as soon as possible. And you can always build on it from there. But people are sometimes, in my experience, wanting to do the fancier things simply because they can, or because they want to be able to put on the resume, I built a real-time processing engine.
Right.
So, you've done a lot of hiring over the years. What are some of the traits or skills, I guess, bringing this back to the other side, when you're looking to hire somebody today? And let's say, you're going to be reviewing resumes this afternoon and doing a couple of phone screens tomorrow. What are some of the key things you're looking for during those conversations and during those resume reviews?
Yeah, so it'd be easy for me to say like a bunch of soft skills. I think, and I think those are very important. but the hard skills have to be there. So there's always this sort of like bar, and hard skills vary by the role and the problems that you're trying to work on. Even within our team, we may hire folks with different hard skills because of the specialty that we think they're going to end up in, or the business they're going to support, and sort of where that business is from a maturity standpoint. So certainly I would say work on the hard skills, make sure that, from both an analytics algorithms and statistics and approaches and those types of things, but also the technical, software development, data platforms, if you can, any of those types of things, any level, any sort of like base level of competency there is super important. And then above that, I think the biggest things are these really tricky things to hire, which are, creativity, curiosity. And then the thing I care about a lot is empathy. And creativity is obviously important. We want, because of what I just mentioned with constraints, if you're constantly trying to understand the problem, and your problem is this sort of complex constrained optimization, then being able to creatively solve that problem versus, every problem's, a nail if you have a hammer, right? If you only know the one approach, and you're going to try to apply it to everything, versus if you have the creativity to try to do interesting solutions and be flexible. So that's certainly one. If it's advice for students, I would say, like, try to understand how things work under the hood, even if you don't build it. Like, understand how it works under the hood, and that'll give you tools to be more creative in how you solve things. An example of that is like we've sort of implemented years and years ago. We sort of implemented this like seasonal adjustment methodology in Excel for some problem, because it was just like we mentioned, it was way too hard to go out and use data science tools, but we still needed to seasonally adjust. And so understanding how all these various algorithms handle seasonal adjustment allowed us to sort of build that logic in Excel, so that if you understand how those things work, you can be more creative in your solutions, and you can get something to someone sort of where they are. Curiosity is obviously important, maybe, but the reason I say it's super important for us when we're hiring is the partners that we work with, they sort of expect us and look to us to really get a deep understanding of the problem. And likely what happens is you think you understand the problem, you think you understand the data, we do some analysis, and you get some result, and it either looks exactly right or it doesn't look quite right. And curiosity is the thing that allows you to pull on that thread and go one level, two levels, three levels deeper, where maybe the real root insight is, or the root cause of something that's interesting. So I think having curiosity and really being passionate about understanding the problem that you're working on is something that we look for. And then lastly, I would say empathy, just because in the way that we engage with our stakeholders, this probably isn't true everywhere, but the way that we engage with our stakeholders, I just think it's really important to understand and have some empathy for what problems they're trying to solve. And so being passionate about understanding the person that you're working with, the problems that they have, and the problems that they're trying to solve, and caring about that enough to make sure that what you build is helping them solve that problem, really helps make sure that we're working on the right things. And again, it avoids some of those traps that people fall into, which is, I'm building the thing that I think is neat, and it doesn't actually work for whoever you're trying to work with or support. So if you can identify whether somebody has that sort of ingrained natural empathy for a partner or a stakeholder, that's certainly something that I look for in hiring. So, I don't know how to identify those. Certainly we have some things that we try to do, and I don't know necessarily how to recommend that folks who are coming out of school develop those skills. But if you can sort of display experience around, creativity in your solutions, not just like that you brute force did something really hard, display curiosity in problems that you're solving, and that you understand things, 1, 2, 3 levels deeper than sort of surface. And then if you can show some empathy, that's certainly something that, we are always looking for.
Well, before we run out of time, I guess just one closing question for you. What do you think, if you look out 3 to 5 years, what's a trend that you see emerging that you think is going to be a major factor in the analytics data science space over 3 to 5 years?
Yeah, I don't know. Like I said, I think prognosticating is probably, I'm not very good at it. And I think maybe as an industry, we're probably not as good at it as we are in other parts of what we do. But obviously, all the the classical AI applications from, speech, text, image, video, all of those things I think are going to continue to be rapidly iterating and innovating. What I think, and I think you've written something about this too, Bill, but what I think is going to be most interesting over the next 5 years, and we've been saying this for maybe 5 years now already, but I think we're really getting to the point where more data science environments and workflows are going to be more defined, and maybe more automation is going to come to that. I think, an example, I think, Bill, you were at Teradata for a while, and 10, 15, 20 years ago, there was entire patterns around building, really big business intelligence solutions on top of these really big, impressive warehouses. But that engineering was totally different. All the tools you use, the workflows you use were totally different than, building a front-end website or building an industrial application. And data science, I think, is sort of a new thing. Like the way that we build, the way that we think, the tools that we use, how those tools integrate. It goes beyond just having an IDE. It goes to sort of integrating across the entire workflow and thinking about how you go from research to production. And I think what we're going to see over the next 5 years is a lot of innovation in that space, probably some consolidation of that space, and then likely some automation, so that tasks that are manual today will be automated, and our jobs will probably change a little bit in terms of how much of what we do is sort of building things very bespoke versus how much of what we do is again picking really, really nice mature tools off a toolbox and just stitching them together to solve a problem.
Well, as you suspected, I think I'm totally in alignment with you on that. So I think you're dead on. You're dead on. That was a good prognostication, even though you were hesitant. So, hey, I know I've taken a lot of your time today. I want to thank you. I think the perspectives you offered today were terrific, and thanks so much for spending your time.
Yeah, thanks for having me, Bill. Enjoyed it.